The first thing we needed to find out was whether the treatment had an impact. Well, to do this, we calculated the difference in the means between the two groups. There was a positive impact with the treatment group having on average $1,794 more in pay than the control group. Next, we wanted to see if this still holds true when the experiment involved a different control group. To do this, we separated the treatment group from the original dataset and then took a new control group and combined it with the separated treatment group. And we call this combine_data. After modifying the dataset, we found that there was actually a negative impact in the new dataset. But this could also be due to the new control dataset not having been prepared the same way the original dataset was. So we cannot yet say that there was actually a negative impact from the program. So to ensure that the treatment and control group consisted of members who were equally likely to get picked for the treatment, we made use of propensity score matching to pair up people such that anyone could have been picked for the treatment. With that established, we have better grounds to draw conclusions about the effect of the treatment. So for the propensity score matching, we prepared a few variables. So we have like a cubic polynomial of the age, a quadratic polynomial in education, and then a marriage variable, no degree, black, hip, Hispanic people. So and so on. We combine that to form the equation for the propensity score matching. And then we assign the new expression to this variable logic underscore formula, and then we passed it to the generalized linear model function, which is available in R by default, and with that we get the propensity scores. And so what we did was then add the propensity scores to the as a new column to the original data set. Once we did that, we then plotted a histogram to see if the output is going to be as expected, which is a level playing ground for picking people for treatment and control groups. And so what we see here is that the propensity scores are not exactly as expected. Ideally, we should have been seeing more of the people in the treatment group towards the right side. That is, we should have been seeing people in the treatment group with a higher propensity score. So we are a bit surprised that the propensity score is actually here, but it's not something that we would be too concerned about, because for one thing, it's also expected that generally propensity scores of the control group and the treatment group should be having a lot of overlap, and we do see that happening over here. So maybe it's just that with our data set, the propensity scores are not too much to the right, but rather in the middle. And with propensity scores at hand, we then had to pair up people with similar scores, and we tried two different methods for pairing. One is the inverse probability weighing, and the other is nearest neighbor matching. And we found that the inverse probability weighing gives a value of 3047, and nearest neighbor matching gives a score of 5310. So now we had to pick which was the more suitable method for our problem. And what we think is, so for nearest neighbor matching, the method works such that it pairs people uh, who are almost identical, like twins. So the pairs are gonna consist of people who are almost like the same. And for our case, we would want pairs of people who are basically the same, so that the measure of impact of the treatment would be done on more fair grounds. So let's just say we have two people who are the exact same, and then we apply a treatment. And if the treatment had a positive impact, then we can say for sure that the impact was due to the treatment alone and no other hidden factors that were unaccounted for. And so that's why we think nearest neighbor matching would be the most suitable matching method for our propensity score matching. And finally, some of the potential caveats and suggestions for our further steps would be that the research experiment could definitely use more quality data. We can never go wrong with trying to get more data to make sure that we are arriving at a conclusion that is um, more safe and not based on like little data that may have a few outliers. And the other is we could also make use of an alternate method to propensity score matching to make sure that we are getting consistent outcome um, in all of these methods. So if we have multiple methods that can be used for the same purpose, and if they all give the same outcome, then there's a higher chance of um, being sure that the outcome is actually uh, correct. And finally, it couldn't hurt to have our whole process peer reviewed, so that any like um, issues or factors that are overlooked can be brought forth.